Okay, good evening everybody. Okay, today we'll run through 3 questions on heat transfer. For these 3 questions, I would like to emphasize on students to take note of the way we analyze the questions to derive at the correct mode of heat transfer. Second one I need you guys to take note is the way I structure my answers to present the relevant mode of heat transfer. Meaning, for conduction, there is a list of keywords or key phrases that I will be using. For convection, there will also be a set of key phrases. Likewise for radiations. Okay, so take note of these key phrases. Okay, if you happen to miss out, okay, you can refer back to the previous 3 videos on conduction, convections, and radiation. I have also listed these keywords in the video itself. Okay, so you can run through to have revision before you proceed on with this particular video. Okay, if you've forgotten about it, no worries. Just rerun the videos, okay, before you proceed on in this particular video. Okay, if you are ready, here we go. Okay, for question 1, okay, you'll find that for question 1, you'll find that the questions pertaining to the air, okay, and air is being used or is one of the main character in these questions when we talk about ice not melting quickly. Okay, what the nurse did was actually he put a second layer of plastic bag, okay, around it. So this is the first layer. So what she did was she actually have another layer of plastic bag, okay, around the first layer. Okay, and after that the questions ask the students is that what does the second layer or the air in the second layers actually helps? How does it help to prevent or reduce the ice from melting? Clues to take note is that we are looking at is that, of course, we are looking at ice melting. Okay, that's like pretty obvious. The other one that we mentioned is that there is the use of second plastic bag, and more importantly is that there is mention of layer of air in between the plastic bag. Okay, so if you look at the layer of air, give me a minute. Okay, it does has a mention of the layer of air. Okay, more importantly, I want to highlight on the fact is air. Okay, so when you talk about air, first thing that run through your head, it could be conduction. Okay, or it could be convection current. Okay, because hot rise, cold sink. So air is a fluid. Possible it could be convection, or it could be also a conduction question. Because why? Because most often air is a bad conductor. Okay, now the thing to take note is that the air exists in between the layers of the plastic bag, which means that the plastic bag is actually clenched tightly. So if you're talking about hot air rises, cold air sinking freely, you'll find that the air is actually trapped in between the plastic bag, so you will not actually see much movement if you're looking at the air movement itself, the cold air and hot air. Okay, so I will say that convection current, because it's not free to move around in between the layers of plastic bag, convection current is actually not likely. So I would say the question actually uses air, and the primary focus on it will be on conduction. Okay, so I will actually structure my questions pertaining to air being used in conduction. So how does conduction works? Okay, in air. Okay, same as before. Okay, take note, the context here is that this is cold. Okay, because ice is present, which means the environment actually is a hotter body. So if you talk about heat transfer will be a certain direction. It will be always from high temp to low temp. Okay, so thermal energy will be actually moving into the ice itself, and this is actually fairly quite true because I need the energy to melt the ice. So how I phrase the question? Okay, remember these 3 phrases, I have actually used them in my video before. Okay, on conduction, you can refer to them. So I will actually state that I will tell the marker that what I know about air itself is actually a bad conductor. Okay, and what does it do? What does it do? It actually reduces heat being conducted to the exterior. Okay, now take note of the direction. The direction that we are referring to is actually from outside to inside. So if you look at the phrasing, you don't copy and paste the answer from the previous examples or from the videos. You need to actually put your answers, put my keywords or my sentence in perspective with the question. So yes, I have to reduce heat loss because it's a bad conductor, but now it's actually the heat is actually from outside to inside. So what I actually need to change is actually to the interior. Okay, remember the tagging keyword: conductor, conduct. Okay, so the second key phrase that we're looking out for is the mention of using of the word conduct and the correct directions. Okay, for this case, it will be from hot to cold, from outside to inside. So it will towards the interior. Okay, and same as before, because it's a bad conductor, heat will actually be conducted at a slower rate. So if you look at all these three keywords and you string them together as into a proper sentence, okay, proper sentences, this will actually be your answer. Okay, for this particular question, it's quite easily done because I would say it's always the same approach. Okay, first one is identify whether it's a bad or good conductor. Second one is to whether it is to increase the conductions or to reduce the conduction, followed by using the correct tagging keyword, which is conducts. Okay, followed by the direction itself, whether it's outside to inside or inside to outside. So you need to monitor that. And the last keyword we're looking for is fast or slow rate. If it's bad conductors, I'm looking at is to slow down. Okay. If it's a good conductor, we will say that the heat is being conducted out or in at a faster pace. Okay, so take note of the clues that we are looking for. Okay, so before I run through this structure, okay, you actually have this structure in the video. You actually have this in your tool bag. So what you need to do is you actually need to analyze the question to derive on the possible mode of heat transfer before you can apply the keyword itself. Same thing for second question here, we're looking at electric oven. Okay, so we are looking at heating elements. Okay, the moment you see heating elements, most likely you're talking about something being heated up. And if you talk about this in oven, so most likely the context that we are looking out for again will be in air. Okay, and true enough, the question mentioned about air being heated up. Okay, explain how the air become hot. Focus is all the air. Okay, so when you're talking about become hot, so you mean automatically everybody should know that the air around the heating elements will become hot. Okay, so the moment you see hot air, first instinct that comes to your mind is same as before. Air, talk about conduction, talk about convection. But the mention about hot air, straight away you will know that this question, when you talk about air, is not just conduction, it's actually about convection current. So the main process that I'm looking out for, because I'm using air and because it's hot air, I actually will structure my answer towards convection. So same thing, the keywords, the key phrases for convection answers are in my video for convection. You can refer to it. Okay, if not, here they are. Okay, in three particular sentences. Okay, so you always talk about hot air. Hot air, you need to mention the increase in volume. After that, you need to talk about what's the aftermath of the increase in volume, which is a smaller density. And as a result of being less dense, it will actually rise up. The second phrases that we're looking for, it will be the cold air. Same thing, I need the phrase denser and sink. Okay, so these are the two key phrases that we always mention when we use convection. And the last sentence will be the process being set up. What process? Convection current being set up. So as long as you have these three keywords or these key phrases in your answer, you'll find that if the question is about convection and you have these three phrases, the 90% of the chance that you will actually have is 100%. Okay, for the marks. Okay, you have a 90% chance that you will get everything correct. What about a 10% chance? 10% chance it could be, okay, the question actually asks for not just the main process, he also asks for the secondary process. So you have to read the question carefully. Okay, if it's asking for both method, convection and the secondary method, for this question first, it will be that the secondary method will be conductions. Okay, because air, same thing, I'm looking at non-matter, gas. Okay, and the method that for conduction here will take place is actually molecular vibrations. So there are actually two methods. One is the main and the other one is the secondary. Okay, so it depends on how much the weightage of the marks is. Okay, so the students, you need to actually choose or analyze your answers and the questions carefully. Okay, now for the last question I'm looking at here is actually counting of two flasks. Okay, I have two glass flasks. I would say the keyword is glass flasks. Okay, they are heated up at room temperature. Okay, and there's a heater in between them, so there's a heater here. After that, one of the keywords from the picture you need to mention is there's a silver, there's a dull surface. So if you look at the clue here, we're looking at the glass. So you're looking at the glass surfaces. Okay, so you look at the glass surfaces, but glass, yes, is an important thing. You talk about medium. Okay, which means most likely you are dealing with conduction. But the good thing is that you have identified that. Okay, the bad thing is that both scenario A and B are actually the same material. So from here you will find that A and B, they are all glass. Okay, the bad news will be that since both of them are glass, glass itself has actually no impact because they are on the same benchmark. So that's the bad thing about this particular clue. Okay, so what about room temperature? Room temperature and the heater. You'll find that room temperature and heater being the guy producing heat, you'll find that heater is actually what we call a hot body. And which means that the room temperature will tell us that the other setup, everything will be at room temperature, which is what we call the cold body. Okay, so with these two statements together, okay, this statement will actually tell us the direction of heat transfer. So it will be from the heater to the body itself. Okay, and likewise, when we talk about silver, we talk about color. Okay, and color, that silver, dull, all these things, dull, black, all these things, we have colors, we have texture. We only look at one particular mode of heat transfer, which is radiations. Okay, so once you analyze the question, you will find that actually the questions here generally will actually require the students to focus their attention on radiations, which is why the first answer here, state the name of the process involved. The answer here will be actually radiations. Okay. Then after that, part B will talk about how to explain the motion of air molecules in each of the flasks. Okay, since it's a radiation question, so the thermal energy will actually move from the heater to the flask itself. And after that, the thermal energy will actually be used to heat up the particles. So how does the thermal energy get across the transfer from the heater to the flask itself? Okay, like you see from here, the clue, it will be by radiations. So, and we also know that it's from outside to inside. So that's why I know that the flask B and flask A, they will be acting as an absorber. So the primary task here, the keywords I'm looking out for radiation, it will be acting as an absorber. Okay, and same as before, one surface is silver, one surface is dull. So there's a difference in color. So which means black being the better absorber. You'll find that one of the keywords that we're looking out for, you have to state that actually B, okay, will absorb more energy from the exterior. Remember, the key phrases here we're looking out for is absorb. Okay, because we already mentioned that black is a good absorber. Okay, so the phrasing is always stating the context. Okay, black or white is a good or bad absorber. Then after that, we say whether it absorb more, absorb less, or emit less, or emit more. Okay, so emitter or absorber, same thing, you check the direction. Okay, so outside is hot, inside is cold, so this will be a classic example of absorbing. So that's why I will know I will use absorber. And because black and silver, so I will know black is a bad absorber here. Same thing, the only extra thing is we talk about is what happened to the motion of the particles. Okay, motion of molecules here is the additional keywords that we have from chapter 8 or maybe from the chemistry. Okay, when you absorb more energy, the molecule actually gains more kinetic energy, and actually it will actually move faster, or it will vibrate more vigorously. Okay, so this section here is the additional keyword, but this keyword actually comes from inference from the question. The question asks for motion of particles. Okay, so it comes from chapter 9, your kinetic model matter. Okay, chapter 7, kinetic model. Okay, your KMT. Okay, or you can look at your chemistry. Okay, so this is the additional keywords that you should actually be mentioning because the question does mention that. Okay, so part C. Okay, what happens to the column of liquid? Okay, so you know that this guy has more energy. So in fact, you will actually, with more energy, you'll find that actually A and B, when they absorb energy, A and B, the vibrations will be there. Both color liquid will actually move up. The flask will actually move up because of vibrations. But it's just that B will vibrate more bombard more and it will exert a larger force. Okay, so take note of how I answer the techniques. Okay, see you.